Okay, good afternoon, ladies and gentlemen, and boys and girls. My name's Michael Davis. I'm the chair of this afternoon's session on exploring careers in space science and technology. It's fantastic to see this number of people turning up and showing an interest in this topic, which is about double the number of people who are interested in careers in medical science, which was the session I attended just before, so that's very gratifying. Before we start, and before I introduce our expert guest speakers, we'd like to know a little bit about you and who you are and what your background is. So if you're a teacher, please put up your hand. Okay, only one.
Two.
Two, only two. Okay.
Stealth up there in the
If
shadows.
you're a primary school person, put up your hand.
Up.
Great. One. How many primary school have we got? One, two?
One, I think.
One or two, well, at least one. That's great. How many secondary school students do we have?
Yeah, substantially
Yeah,
more. Yeah,
a good number,
That's a good number.
maybe 25, 30%. How many university students do we have? Undergraduates, first of all. How many undergrads? Keep your hand up if you're doing engineering or science. Okay.
most of them.
Put your hand up if you're not doing engineering or science, but you're an undergraduate. So what are you doing? What are you studying?
I'm here with my friends, so I'm actually doing behavioral science.
Right.
Yep.
Okay.
Human factor is very important.
That's
if you look
very
at it.
important.
Oh yeah.
Very
On Mars
important.
it is. Yeah.
Yeah. Anyone else? Any other undergrads not doing engineering or science?
I'm doing software. Is that part of science, or do you mean more?
Sorry, what are you doing?
Software.
Software. Well, no, that's slightly different. That's a different discipline.
But it fits into the engineering world.
Yeah, it counts.
But very, very relevant to this sector of the economy. Any postgrads, researchers? Yes.
A couple.
What's your field?
Project management.
Project management. Up the back? Astrophysics.
That fits into the space field.
Yeah, that sort of fits in. Anyone else?
The
Yes.
fellow at the front.
Biomedical science. Environmental.
Yeah.
Environmental science. Yes? Cybersecurity. Very important. Very important. Anyone else? Yes?
Data science.
Sorry? Data science. Yes? So has anyone not put up their hand yet?
What about the mums and dads?
Ah, okay. So we've got, okay, mums and dads. How many parents do we have here? Yeah, well, you have a big say in all of this, so that's great. Anyone else? Okay, well, that is good for us because that gives us a feel for who we're talking to and what your likely interests are going to be. And I think one of the fantastic things about this sector, and when I say this sector, I'm talking about the space sector, which is defined, we can define very broadly. And our expert speakers will explain to you some of the many dimensions of the space sector in Australia and internationally. But one of the things that features of this sector is that it involves many, many disciplines. It's perfectly true that the majority of professionals working in the space sector are engineers or scientists, but you need more than engineers and scientists. You need project managers, you need IT specialists, you need doctors, you need lawyers, you need business people, you need policy experts, you need military officers, and you will probably hear that a very large amount of the work involved in space science and technology is under the umbrella of defence programs. And so we find that there are more and more Air Force officers, Army officers, Navy officers who are being educated in relation to various aspects of space operations. So there are many, many ways of getting into this sector. But I guess the important message for those of you who are still at school is that the way to ensure a career path into this sector is to be really good at the maths and sciences. And by doing that, you qualify yourself for aerospace engineering as a possible career path at various Australian universities, or possibly other technical disciplines like IT, etc., etc. So the majority of jobs will be for those with those young professionals with qualifications in the technical disciplines. But there is a minority of jobs and there is a smaller group of jobs for people from many other backgrounds. So if you're studying medicine or law or medical science or a non-scientific discipline, you're not excluded, and hopefully we'll be able to touch on the opportunities for people with those qualifications as well. The only other thing I want to say before I introduce the speakers is that one of the things I do is to chair the management committee for the Southern Hemisphere Space Studies program. And this, for graduates or for senior undergraduates, is a wonderful way of becoming involved in the space sector, not only in Australia but internationally. It's a 5-week intensive program we do every year in Adelaide at the University of South Australia, and it's organised in partnership between the University of South Australia and the International Space University. And the International Space University is the university that I attended 25 years ago when I obtained my Master of Space Studies degree. And it's a small university with its headquarters in Strasbourg in France that offers a master's program for people with undergraduate degrees, and a 9-week program in the Northern Hemisphere summer, and a 5-week program in the Southern Hemisphere in Adelaide. And so for anyone who lives here, it's a wonderful opportunity if you qualify, if you've got the right qualifications. Our next program starts on the 15th of January and it will run for 5 weeks. We're holding 4 public events to which you're all invited. So please look out for the advertising for our 4 public events. One of them will be an international astronaut panel, and others will be very high-profile speakers on various aspects to do with space: cosmology, engineering, science, policy, politics, law, etc. So watch out for that. So with that, I would like now to introduce our 3 speakers very briefly. On my far left is Professor Peter Ashman, who is Deputy Dean of Engineering and Computer Science at Adelaide University. And then Dr. Petty Newman from Newman Space, and I'll let Petty explain to you what he does in Adelaide. And lastly, Mr. Peter Nikolov, who is a director of a very prominent and important space engineering and consulting company in Adelaide, with its headquarters in Adelaide, called Nova Systems. So I'd like to start by inviting Peter to say a few words.
Thanks, Michael. Now, I love speaking to young people, especially if they're interested in space and technology. So welcome, and I'm glad you guys came along. I was probably like a bunch of you guys when I was very, very young. I had a really, really strong focus and interest in space. I'm a bit older than most of you guys, so I was around when they were doing the moon landing type stuff. And Mum used to say that I used to get the encyclopedia out, because they didn't have internets back in those days, and go to the S section and just look at all the pictures of the Apollo program and people working on the moon and things like that. So I've been passionate about space my whole life. And to get into space, we obviously didn't have a space program or astronauts. I actually thought, what's the best way to do that? So I sort of channeled myself into engineering and aerospace engineering. So I did that in Melbourne in the 80s, worked with the Defence Science Technology Group on air weapons, transferred to Air Force, and then spent a lot of my time working with F-18 aircraft, so testing all the new systems and capabilities on that. I was lucky enough to be a test engineer and sitting in the back seat. And we used to use the Woomera rocket range for testing our aircraft and weapons. And as I guess a lot of the adults might know, the kids might not, but the Woomera rocket range is where they've actually launched a whole bunch of rockets for research and other activities during the, well, they started rocket testing in the 50s all the way up to the 70s, then Air Force now run the range. So that's a very exciting place. So Nova Systems, it's an Australian wholly owned company by myself and the partner. He was a F-18 test pilot. We're headquartered in Adelaide, and we've now got over 500 staff, most of them in Australia, but got some in the UK and the US. And a lot of our work is helping with very complex systems for the military, so with aerospace, maritime, the ships and submarines, Army command and control systems, and satellite communication systems. That's the fastest growing area for our company. So we do a lot of that, most of that work in Australia, so there is lots of jobs. We can't employ enough people at the moment. Now, it is a very high-tech workforce, but as Michael was saying, we mainly employ engineers, but the disciplines are broad. We employ everyone from aerospace engineers, mechanical engineers, electrical engineers, communications engineers, chemical engineers. They even work with a lot of the rockets and weapon systems as well. Software engineers, we've got cyber people, people doing big data. So whatever you can think of in the engineering technology field, it touches space, as Michael said. Now, some of the stuff we do, these are projects that have happened. Whoa, I wasn't even touching that. It's magic. So,
Put it down.
I think you've got a timing thing on you.
Yeah, I think so. Yeah.
that's spooky. Quick, have a quick look at that. On the left, you see rocket ranges. That's an area where I worked. I'll have to manually override this. And the rocket range is actually based, I'll let it go and I'll jump back to it. There's the Woomera rocket range. It's the biggest test range in the world. And we've been using that for rocket testing right up to today. So even when the British pulled out and we finished all those early day rocket testing, we're now doing a lot of work with hypersonic technology. So that's things that can fly more than 5 times the speed of sound. And that's absolutely amazing. We're doing an international program with the Americans and Australia. And that technology is really the future. To fly, this is like 2 or 3 times faster than Concorde can fly. But can you imagine transport moving around the world? You won't have to sit on a plane for 20 hours to fly to the other part of the world. You'd probably get there in like 2 hours. So there's some great work, and that's happening in Australia. There's a whole lot of research happening with defence science. There's research happening in universities. So that's in your backyard. I'll keep going. Oh, that's sort of the equipment you deal with. These radars track a lot of the spacecraft we launch, and also a lot of the aircraft for testing. Optical trackers, so you can look at things and see how it's performing. And this is some of the launch equipment we have at Woomera. So that rocket on the left is one of the hypersonic test vehicles. That one I think that went to about twice the height of the International Space Station, which is really cool. So we had to ring up NASA and NORAD and speak to The Hague and get to say, look, well, this isn't a nuclear attack on anyone. We're just doing some testing. And the other rocket is a test on the right-hand side. We're doing the Japanese. So they use the rocket to launch an aeroplane and tested it twice the speed of sound. So really cool stuff happening in South Australia. That's the launch of the hypersonic vehicle I was talking about. Woomera rocket range, one of the things that we did do back in the 60s, Australia was one of I think the 3rd country in the world to actually build its own satellite and have it launched into space from its own block of land. So we used Woomera. And that's just had its 50th anniversary yesterday. Yeah, yesterday. So that's great, and we're really pushing now. With you might have heard we've got the government to start establishing a space agency, and we basically part of that program will be encouraging Australian space sector to build more space-based systems like satellites and things like that. Another great project, working with the Japanese. That little spacecraft you can see there, I'm the good-looking guy on the left. That spacecraft the Japanese sent out sort of hundreds of millions of miles from an asteroid, got a little bit of dirt, and they brought it back to Woomera, because we've got the biggest test range. And that little capsule there on the bottom right, that had the dirt in it. And it was one of our young PhD student, Sarah, that was the first person to identify that. She was on the recovery team. So again, this stuff happened in our backyard. And also, Andy Thomas. He was like me, very passionate with space, but he had to go to America to become an astronaut. But it's possible, anyone can become an astronaut if you've got enough drive. And with Australia setting up a space agency, having more relationships with agencies around the world, those opportunities may become a lot more real in the future. And the slide which I missed, that one kept sort of running past, we are doing lots of work with satellite communications as well. That's another area we can't employ enough people in. And we're helping the Department of Defence with a lot of the ground stations and testing some of the new satellites and equipment they're bringing into service. So that's to support the military with secure communication. So there's lots of work there. We're just trying to grow and employ more people. So if you want to work in some of those areas, you can do that as well. Well, I better move on so the others can have a quick chat, and maybe we'll do the questions at the end.
Yeah.
Yep.
All right. Thank you, Peter. Well, our next speaker is Dr. Petty Newman, who is a fairly new South Australian, if I may describe you that way.
Yeah, sure, no worries.
I think you were educated in Sydney in physics or engineering, or both?
Both, actually.
Both.
Yeah.
And Petty is one of the new breed of entrepreneurs who actually has started his own space company, and he has decided that Adelaide in South Australia is an excellent place for him to do the very exciting work that he'll describe to you. And so it gives me great pleasure to invite Paddy to say a few words to you.
Thank you, Michael. So, g'day, I'm Paddy, and I'm a rocket scientist. I got that way kind of similar to how Pete got the way he is today. I was also really keen about space. I'm not quite of the right vintage to have watched moon landings, but like a lot of kids, I was mad keen on dinosaurs and thought dinosaurs were really great. And reading all the books on dinosaurs, saw that they were killed off by an asteroid, which then begged the question, what the hell's an asteroid? And started reading up about that, and this was me at like 5 years old, a little baby Paddy, and this was about the time when Voyager 2 was about to do its flyby of Neptune. So I was the kid that, you know, threw a tantrum and held his breath and finally managed to convince my parents to let me stay up to the ungodly hour of all of 10:30, I think it was, to watch the live cross from NASA JPL on Quantum, so I could watch the data being streamed down from the Neptune encounter. And it was great. It was really cool. And so I wound up being the kid who'd go down to the Shire Library, do interlibrary loans to the State Library, and get the Voyager mission reports from Jupiter and Saturn encounters and go poring over those, especially the maps. And especially noticing the big empty bits on the maps. And thinking, all right, more stuff to find out. You're gonna eventually run out of stuff to find out about dinosaurs because it happened a long time ago, but space keeps going on forever, right? That's why I wound up transitioning into space. And then when I was about 8, I realized I couldn't be an astronaut because I was an American and I'd have to move to the States, and I was 8, and that just wasn't going to happen. So I thought, okay, we'll go and do engineering, right? And so I studied hard, ate all my vegetables, got enough sleep, and did well enough in my exams to be able to get a scholarship to the University of Sydney. I grew up in the hills east of Perth, so this was a big shift. Got to Sydney Uni. Was a rather uninspiring undergraduate student because I keep falling asleep in lectures. Yeah, if you do fall asleep in lectures, don't worry. You find out a way of getting around this problem and you can keep moving forward. With me, it was have a good, strong cup of tea and find something else to do as well so you can make up your marks somewhere else. For me, it was experimental projects, because if you're in the lab, you don't fall asleep because you're with a lot of hazardous machinery, and if you do fall asleep, you're taking your life in your own hands. Doing a bunch of projects, I noticed a couple of interesting things about some of the plasma sources that were being used at the University of Sydney, and figured you could make a rocket out of one of them. I needed an honours project, and so my honours project was, is this a thruster? Does it produce thrust? If so, how the hell do I measure it? It would produce thrust in a different way. Is there a different scale to anything else, so you couldn't use any of the regular off-the-shelf ways of doing this? And the solution I had was you stick a bit of overhead projector film in front of it, and you work it like a pendulum. You measure how fast the pendulum's moving, and you measure how much the pendulum weighs, and it tells you how much momentum and thus thrust you've put onto the pendulum. And it works pretty damn well, and follow the various rabbits down their rabbit holes, and found out how efficient the system was, and it kind of blew my mind. And like all good scientists, I spent 2 months trying to figure out where the hell I'd gone wrong, because my numbers were too damn good. Turns out I hadn't made any mistakes, and it really was as efficient as the numbers suggest, and decided to form my own company to try and commercialize this, because our rocket has a lot of benefits in the way it works. It's really, really efficient. You need to use a very small amount of fuel to move your spacecraft around in space. Our system is only usable in space because it needs vacuum. If you've got too many air molecules in the way, the reaction stops dead. But really efficient, a lot less fuel, a lot less stuff you need to carry into orbit. The fuel is like solid metal because our system works like an arc welder. So the engineering would be a lot simpler, we reckon, than a lot of current generation systems. So we formed the company. We moved here to Adelaide for a number of reasons. Chief amongst them is the history, and the history which is realised in the engineering capabilities of firms around Adelaide. We could try building it all ourselves, but we'd be foolish to try that. There are a number of companies who can build aerospace-grade hardware and do so today, and have the skills and the techniques and the technologies to build it. That's one reason we moved here. Another one was this is where Australia does a lot of its defence research as well, so we'd be able to tap into those networks and get the help for the things at which we are crap, because no one can be good at anything. I'm a propulsion geek. I'm terrible at circuit design. I'm terrible at real-time control systems. However, there are people around there who are really good at these things, and if you can get tapped into those networks, that can help you out. And additionally, I studied in Sydney. My God, the rent. Of course we'd bloody well move here. I can get the place we've got up the road in Brompton where we've got our lab set up is a quarter the cost of an equivalent space in an equivalent suburb of Sydney. We'd be foolish to try and stay there. So yeah, that's...
So stay in Adelaide, guys.
Yeah, it's a beautiful part of the world. And yeah, it's how I got here. And after the next speakers introduce themselves, I will happily take questions about stuff. No worries.
Just before you finish, who do you employ in Adelaide? How many people have you got?
We've got 8 full-timers, including myself in the company, including 3 people recently graduated from the University of Adelaide, 2 of them mechatronics engineers, one of them who has come out of architecture but also specialised in project management. Engineers are great at what they do, but when you look at the entire project, they're focused on their part of it, and you need someone to move the entire project along. So project management is a necessary skill set for this business.
Just a quick one on that. He talked about mechatronics, and mechatronics is where you mix mechanical engineering, so you can build things like structures or bits of a robot, and the electronic side is working out how you control it. So that's really one of the big sort of future careers if you really want to get into complex systems and things like that. So it's really exciting. We see some great projects come out of mechatronics areas. Sorry, I just thought I'd explain to the young kids.
Oh, yeah, of course. Please.
Yeah.
Thank you.
Yeah.
Well, this is a very good segue to Professor Peter Ashman, who is from the, or Deputy Dean of the Engineering and IT School at Adelaide University. Adelaide University, as many of you know, is one of Australia's leading universities and is doing some very exciting things in space engineering, space science, and also space law. You're probably aware of what's happening in that part of Adelaide University, but it gives me great pleasure to invite Peter to say a few words.
Michael. And a long history in space, and
Yes,
I only recently
absolutely.
found out that the School of Physics, University of Adelaide, were very important in
50 years ago.
Yeah, 50 years ago.
Yes, absolutely.
Yeah. So, as Michael said, I'm from the University of Adelaide. I don't have a personal connection to the space industry. I'm here basically to tell you a little bit more about some of the ways that you might engage with the various universities, and I don't want to focus too much on Adelaide. I mean, I'll be plugging for Adelaide, but UniSA and Flinders offer similar programs in lots of the different areas that I might mention. One of the roles that I have as Deputy Dean is to sort of look after our educational offerings in both defence and security, but also space, and so that's, I guess, why I'm here. I'm a chemical engineer by training, and as Peter said, chemical engineers also find their way into the space industry. I'm aware of a few chemical engineers that have actually flown in space as mission specialists, looking at things like combustion in microgravity and various things like that. I thought I'd mention a few of our alumni. I mean, our alumni are our best ambassadors, and given that I don't have a personal connection with space, but I'm aware of some of our alumni that do, and we recently had a very big, some of you I'm sure would have been there, the big International Astronautical Congress in Adelaide, and we were able to get some of our alumni from the space industry in the one place at the one time, which was great, and we put on a bit of an event at the university, and so I got to catch up with a few of our great alumni. Andy Thomas we've already talked about, and I'm sure you're all of you are aware of Andy's great work in space, but one of the great things that Andy did was inspire the next generation of space scientists and space engineers, and some people that you might not be so aware of is someone like Dr. Kimberly Clayfield, who's Executive Manager of Space Sciences and Technology at CSIRO. Kimberly has a degree in mechanical engineering and also a PhD in fluid mechanics and combustion, and her role at CSIRO is to coordinate and support all of CSIRO's space-related activities, and I suspect Kimberly may have a key role in shaping what our space agency might look like in the future. Someone else who was there was Dr. Justin Hardy, who's head of combustion dynamics groups at DLR, Germany's National Research Centre, so another rocket scientist. And he gets to, as these guys do, gets to fire rockets for a living, which is just a cool job. He also has a PhD in propulsion engineering from the University of Adelaide, but his PhD was quite interesting. Then while his degree was awarded from the university, he was enrolled at Adelaide and had supervision here. He spent most of his time at DLR in Germany using their facilities. And then the third person I wanted to mention was Andrea Boyd, who's a flight operations engineer at the International Space Station, ISS. Station. And so she gets to talk to astronauts on a daily basis, and they report into Andrea, where she's based in Germany. Andrea she has a degree in mechanical engineering as well, but her specialty is mechatronics, and she actually spent 10 years working in minerals. I think she worked for BHP for 10 years up at Roxby, but was similarly, and I think there's a common theme we're hearing here, doesn't really matter what you do in terms of studying. I think the only prerequisite you need to get into the space industry is a passion for space, and Andrea certainly has that, and Andrea played a big role in the IAC coming to Adelaide. She's played a big role in getting the government to agree to set up a space agency, and she's another great ambassador for the space industry. The other thing Michael mentioned, it's not just engineering, of course, that gets involved in space. We have one of the world's leading space law centres at the University of Adelaide, and it's an important part of space, the law. I remember when we had students working with Matt Tetlow on the CubeSat. The contract that we had to sign, the agreement we had to sign to send a few kilograms of payload up into space was literally that thick. And as I was acting dean at the time, I had to sign the contract. It's a big deal.
Bigger than the satellite itself.
Oh, probably, yeah.
Definitely by mass. Oh boy.
So it's not just engineering, it's right across the various things that Michael mentioned. The other thing I would also thought I'd chuck in just before we move to questions was the other thing that struck me about all of those people, I think maybe with the exception of Kimberly, all of them speak a second language. Andy had to learn Russian when he was on the Mir space station. Justin speaks German, and who else have I got?
Andrea.
Andrea, also speaks a number of languages because of her role in currently living in Europe. So it's not just maths and science, get onto those languages as well. So I'll pass back to you, Mike.
Thank you, Peter. Before I open up the Q&A, there's one other person in the audience who I'm going to invite to tell you what he does. And this is entirely without warning, but this person over here has a very interesting story to tell you.
Come on, Lawrence.
So his name is Lawrence Trevor, and he's an engineer. But tell us what you do.
All right, so yeah, my name's Lawrence Trevor. I grew up in Sydney. I studied at Sydney Uni doing physics and maths. Sort of fell into a honours project, actually similar to Paddy here, on plasma propulsion systems, and sort of developed a passion for space, and through one thing or another, going through different conferences and meeting the right people, eventually got a job with Pete Nick over here at his company at Nova Systems, taking me on as a SATCOM engineer. And I've also been to SHSSP, so I feel like I really span quite a lot of these people. So if you want to talk about SHSSP, by the way, you can come and chat to me. And yeah, so recently I've just started working at Fleet Space Technologies, and I've had all of today and all of yesterday to perfect my spiel on this, so hopefully it goes really well. So we're a space startup in Adelaide. We're effectively an Internet of Things company. But what we want to do is to bring a global satellite communication network for Internet of Things, sort of getting devices to talk to each other all over the world. So it was set up by a woman called Flavia Tartanadini, who comes from Italy. She's an old propulsion engineer, and she worked for the European Space Agency. And one way or another, she ended up in Adelaide and was like, hey, let's start a satellite company. So she worked her ass off and eventually secured some venture capitalist funding. And here we are. We've actually started a company here. So what we do, we're planning on launching 2 satellites next year to start off our constellation. And we've got a really dedicated team of engineers who are building all sorts of really cool ground tech, working on sort of low power communication networks and, talking to sensors out in the field. I should say that the target markets for what we're trying to do are sort of, for example, precision agriculture, where you have, in the middle of South Australia, you'll have a farm that spans hundreds of acres, and they want to have sensors on the ground to pick up this information. And what you'll find is that the way to get this back to, the farmer who wants to make a decision is based on terrestrial internet. So we want to try and remove the requirement to having a terrestrial internet connection or a mobile internet connection, and basically use satellites to connect all this stuff together. So it's pretty cool. It's a good dream to follow, and it's been a lot of fun so far. Yeah.
How many people work for Fleet, and what are their backgrounds?
Yep. So we've got about 15 people working at Fleet at the moment. They are primarily engineers. I mean, I'm a science graduate, but I've sort of fallen into an engineering profession now. We've got software engineers, mechatronic engineers, electrical engineers. Obviously, Flavia is a propulsion engineer. Lots of telecommunication people as well. Doing SATCOM as well, some of the stuff I've learnt. Yeah.
Great. All right. Well, please thank Lawrence for his unrehearsed contribution. Okay, so now it's your opportunity to ask us questions that hopefully we know the answer to. But please just put up your hand. Is there a mic that is floating around? Okay, put up your hand and then we'll bring you a microphone so we can all hear. So ask us anything.
I've got a question.
Yeah.
For that little girl over there.
Yeah. Oh, yeah.
What does my daughter's looks like about your size. Yeah. What do you want to do when you grow up?
Well, having heard what you've heard today,
yeah. You don't know yet. Is this exciting, some of this space stuff? Yeah, because my daughter wants to do astrophysics. I thought, that's crazy. It's because I took her to sort of talks like this, and she sees it's a really exciting way of the future. So no, space technology is really, really cool. Robots, all sorts of things like that.
That's right. Okay, up the back.
Yep. Hey guys, my name's James, and my question's for Peter Nikolov. I'm just wondering, when you said that hypersonic missile or whatever it was.
Yeah, the test vehicle. Yep.
Test vehicle. That's one. Sorry. You sent it up, and you said you had to talk to NASA about like what was up there, basically.
Yep.
So what was your conversation with NASA about? Was it mostly just letting them know that you were doing it, or was it?
Yeah, it's actually you're actually going to make sure you deconflict with the assets like the space station, but you also speak to NORAD or the US Air Force. They've got a huge database of where everything is. So it's basically making sure you reduce the probability of actually hitting something by accident. And Australia's just, again, this is more great engineering. There's so much stuff in orbit these days, and especially in low Earth orbit where we've got all our CubeSats just starting to launch up. And there's lots of rubbish up there as well. You've probably heard about it on TV. And so Australia's just set up a partnership with the Americans on helping to track all this debris and operational satellites in space, specifically to try and help people deconflict with it and things like that. So they just put a radar in on the West Australian coast, and they're about to put in one of the world's most advanced optical telescopes to look for objects in space. So these projects happening in Australia, and in Canberra, we've got an Australian company working with the Americans and the Australian Air Force as well, using lasers to track objects. So all this stuff's happening in Australia. So it's not just military people involved with these, but there's a lot of companies working in it as well. So there's some really interesting things happening, and that's going to be so important in the future, because people are talking about sending up thousands and thousands of these little satellites. So it's even though space is very big, they can still hit each other, and that causes lots of problems with debris and junk and stuff like that.
Yeah, the space is big, but the really useful parts, they're not that big, and they're getting kind of crowded. So, you call up NASA, it's not a case of, hi NASA, can I have permission? Because you're not a US company, right? It's a case of, hi NASA, we're going to be doing this. We're thinking about, 2 o'clock our time. Is there a chance of us hitting anything that you know about? We want it back and we don't want to leave a mess, sort of thing.
Yeah. Just while the microphone's moving around, a quick question for Peter. Aerospace engineering at Adelaide University.
Yes.
How difficult is it to get into that particular degree?
Yeah, so it's really no different from all of our engineering degrees. Basically, we set a minimum ATAR of 80 for engineering degrees. Now, sometimes they can go up and down, really just depending on the popularity of the course. It doesn't really reflect, to be honest, whether a course is harder or easier than others. In the sort of the days that Kimberly and those guys were going through aerospace, we had ATARs up in the 90s simply because we had limited places within the program.
High demand.
And there was a high demand. These days, to be honest, the demand's not as high as it was in those days.
Okay.
Maybe it'll pick up in the future.
Yeah, and I think a number of other universities have decided to offer similar degrees. Is that right?
I think as it ramps up, I'm sure it will become a thing, something that lots of universities will be thinking about.
Yeah. And
when I did it, for example, I did aerospace engineering in the 80s, and there was only 2 courses. There's one in Melbourne and one in Sydney.
Yeah.
So it was quite hard to get access. But now I think most big universities have got an engineering degree where you can focus on space.
Yeah.
Any other questions?
There we go.
Where's the mic? Maybe down the front here first, and then up the back to
Then there's one up back middle.
Lawrence.
Cardio.
Good exercise.
I've got a question for Patty and others. With the sort of advent of the space agency coming in, how would you like to see the space agency work for you to help you as a space startup and entrepreneur?
Yeah, excellent question. Space agency, announcement at the IAC was a case of, yeah, sure, please stop telling the expert review panel we should have one. That's been received loud and clear. We're going to have one. Could you please start telling them what do you reckon it should do, how it should be structured instead? And at the end of the day, what a national space agency has to do is it has to work in the national interest. What that interest might be, this is always up for discussion. An Australian space agency would be well suited to do, for example, Earth observation, to look at the various things that are interesting to Australia and Australians, but aren't that interesting to a lot of other people around the world. An example is dry land salinity, because this is a problem for agriculture in marginal parts of southern and southwestern Australia. This would require its own little mission, and this is where it could come into helping out small Australian space businesses. Because if you want to do something in space, obviously you've got to build a satellite and it's got to get launched somehow. What Australian companies have or are developing the capability to do is to perform all the various parts of a space mission. A space mission has a number of segments. You've got the launch segment. It's like it says on the tin, it's what launches the stuff into space. The space segment, because it's got to have something in space for it to be a space mission, really. The ground segment, because you're going to want your satellite to be able to talk back to Earth, and your support segment, which enables everything else to work. So starting with the support segment first, there's the Advanced Instrumentation Testing Facility at Mount Stromlo in Canberra, which has the capability to test satellites and satellite componentry so that you know it works on the ground after you shake it up on the table to simulate launch stress, after you put it in a vacuum chamber and simulate the thermal stresses of orbit. This is something we already have. The ground facilities, well, we've got a lot of NASA ground stations, we've got a couple of European Space Agency stations. We've also got some university-based ground stations and some defense ground stations as well. So the ground segment we're already working on with the hardware. As far as software goes, that's a mob in Sydney called Sabre Astronautics who are working on some really cool software solutions to help make ground control a lot easier. Space segment. You've got various manufacturers such as Toolcraft who can build the hardware. You've got the very cunning people over at Innovora and Miriota who are looking at circuit board design and telecommunications design for the communications infrastructure and expertise. There's the group within Nova Systems.
BAE Systems, they can make space.
Exactly too, yeah.
Space-grade equipment.
Yeah. Other various componentry for the satellite. Well, I'm working on propulsion. It's a highly efficient propulsion system. I'd bid on that contract. Yeah, sure, no worries. Launch segment, there's a mob in Queensland working on a new type of chemical rocket. It's not really a new type, but it's a new wrinkle on the type called a hybrid rocket. Rather than a solid fuel where you just light the fuse and hope the explosives explode at the correct rate, or a liquid-fueled rocket where you've combined two liquids and hope they burn at the right rate. You have your solid fuel and you put a liquid oxidizer through it. In their case, paraffin wax and high-purity hydrogen peroxide. And Gilmore Space, as these guys call their company, have a lot of good results on this. They're doing really good work on this, and they're developing orbital launch capability indigenously in Australia. So we've gone through support, launch, ground, and space segments. This is how a putative future Australian Space Agency could support the development of Australian capability and Australian industry by doing something in space that would directly benefit the rest of the nation and serve the nation's interest. So it's a long way of getting there, and please, I'd like the input from the rest of the panel.
So just to summarise, you've heard a little bit about human spaceflight and astronauts and exploring the solar system, but the jobs and the opportunities are really around technologies to do with developing, launching satellites, using satellites in space, and also there's a lot of jobs around the use of data from satellites in space, whether that's GPS data or images. This is where there are many opportunities. And so when you're thinking about possible careers, look to where the opportunities are. And they tend to be around the use of satellites, either getting them up there, operating them while they're in orbit, or using the data back on Earth.
I think the other point, Michael, is while we've been talking about the range of skills and professions that work in space, the other way is to look at it is once you have one of those skills or professions, you can apply them across a whole range of different industries. True. Space, defence, renewable energy, smart tech, health tech,
Yes.
And one of the reasons I think that the governments are investing in space and defence is to really establish that advanced manufacturing capability in Australia.
Yes, absolutely. You may start in one sector and find that you move on to another and come back or whatever. So you're mobile, you're transportable with this sort of qualification. Question up the back?
Yeah. Hey, I'm Sam. So I'm doing first year aerospace engineering at Adelaide.
Yeah.
And my final goal is to become an astronaut. What are your guys' biggest tips or advice on getting there?
Well, I'll start and I'll let the others comment. I did quite a lot of work at the International Space University counselling their students on careers, and it was a lot of fun, but also hard work. They would pay me to go there for a week, and I would have hourly sessions for about 40 hours during the week interviewing all their students. And yes, many people like you, and I'm sure there are others in the audience, have a dream of flying in space, and we encourage that. Never give up on your dream. But I always say when I'm, one-to-one interviews with people, counselling them on their careers in space, if you want to be an astronaut, you have to be really good at something else first. You are not going to be selected as an astronaut, as a mission specialist or a payload specialist, or even as a pilot or a person more involved in the actual operation of the whatever spacecraft it may be, unless you are really, really good at your first career. So being an astronaut is a second career for all of them. They were all selected because of their excellence at some other field, in some other field. Many of them were test pilots who excelled as test pilots, but they were also engineers, scientists, IT specialists, and many of them were able to demonstrate their ability to move from one field of expertise to another. And if you talk to astronauts who've flown on missions, they say, well, most of their time in space is being able to handle many, many different jobs involving many, many different skills. So an interdisciplinary approach to developing your career is also important.
Yeah, on that one, referring to the specialist skill set, when the manned spaceflight program started, they were all test pilots and engineers because it was all about designing, developing spacecraft technologies. These days, that is the small element in the astronaut corps. The astronauts these days are, like Michael said, they're all mission specialists. They got doctors or PhDs in whether it's space medicine or some manufacturing technologies or whatever, research, Earth observation, oceanography. So it's crucial that you actually work out what you're really passionate about as well in those areas. But in the future, my hope or vision of actually, with sort of spending all this time helping to bring the ISA here and ultimately getting Australia to think about a space agency, is that we do have partnerships and relationships with international space agencies around the world. And ultimately, even though we're not going to be a big player, I would love Australia to have involvement with some small niche sort of high-tech area on some international program which could get us involved with going to the other planets in a human space aspect. So we all should be working towards that, because I think that's important, because that's what excites people. That's what human endeavour, exploring and doing things like that is really, really important. And my view is we should be pushing for Australia to be involved globally, so you guys, the next generation, can involve with the exciting programs. You can be astronauts. You can explore other planets and things like that as well. So,
Near-term, near-term direct thing is Graviska po-ruski. How's your Russian? Because they're the people who can launch you into space near-term. And if you're inside a Russian capsule, you need to be able to read Russian because everything's labeled in Russian. You need to be able to speak Russian fluently so that if everything goes well, you can still talk to people on the ground. But if everything goes very wrong, the people on the ground snapping things rapidly in rapid-fire Russian go through a dodgy communications link, you can still understand what they're saying. So this is why a lot of the people who work in space speak another language. Additionally, again, near term, we don't quite know what the Australian Space Agency is going to be like. We hope like hell it's going to have these international collaborations because it'd be foolish not to. But if it chooses not to, for some bizarre reason, do you have another citizenship that you can use? Are you able to claim American citizenship and go through NASA? Canadian or any of the European nations' citizenship and go through ESA? Can you claim any of the citizenship through any of the other nations part of the ISS consortium and be part of that program? To build on what the others have said, sure, you can qualify for the astronaut corps, but what are you going to do when you're up there? You mentioned mechanical and aerospace engineering. These are fine things to do. Excel at this. Become the person who knows a lot about one of the systems on board the space station or any of the other future vehicles under development so that you can operate it, you can fix it, you can troubleshoot it. You can, when you're not doing that, do other bits and pieces. Develop hobbies. Tinker. Learn how to fix things. Most of what the astronauts do on the space station is janitorial work. Keeping the damn thing going takes about, I believe it's about 5 man-days per day. So if you've got 6 people there, 5 of them have their full-time job of keeping it working. So
and safe.
And safe, right? So they're really happy that they reckon they've expanded the life support so they can fully support 7 people up there. So now it's 2 people who are spare to do experiments. So by sending up 1 extra person, they've effectively doubled the usable work time on the station. So it's not just how can I become an astronaut, it's how am I going to be attractive enough to the people selecting astronauts to make them want to pick me, my skill sets? What can I bring to the table? Yeah. So I do commend this. It's definitely a goal. It's highly ambitious. Best of luck with it. But you need to think about what they want as well.
Yeah. So, I mean, I think it's all been covered. I might just mention that the T-shaped professional, so we talk about the T-shaped professional as being someone who is very broad in their school base and be able to do lots of things along the top of the T, but also very deep discipline knowledge. And, you know, Michael mentioned being an expert. Without raining on your parade, I mean, aspiring to go into space is a bit like aspiring to play full forward for the Crows. You know, lots of people want to do it. Not many people will get that opportunity, and to get there, you're going to have to be the best of the best. So, yeah.
Yes.
I just wanted to hear your comments on asteroid mining and the future for that.
I've spent a lot of time going to conferences and things like that around the world, and there's actually a big uprising of industry starting to invest their own money into those sort of technologies and things like that. And one of the advantages of getting resources from space, and NASA's very interested in this, if we have to go to Mars, quite often, not often, it is a lot more expensive to launch stuff off the Earth because the gravity, we've got to get through the big gravity well here. So if you can mine materials from an asteroid and then just moving that to Mars or another planet is so much easier and cheaper and costs a lot less energy. So there's that one aspect that I think probably be the initial, I guess, mining requirements will be support Mars and other activities. But then a lot of these other entrepreneurs and rich people are saying, well, the resources on Earth are running out. We've got some really sort of rare materials out there. Let's dig it up and become rich as well. But I think initially it will be used to support moon bases or Mars bases and things like that. Yeah. And NASA was sort of driving a lot of that sort of energy, I think, for people working in that area.
It's not so much NASA saying we're going to go out and mine there as NASA saying, yeah, it'd be really good if people could do this, and putting out requests for people to do design work and do the necessary background, so that at some point you have company X saying, okay, we've got the various technology that kind of works on Earth. They'll be able to, approach NASA for a grant and put something in space for some testing, and then NASA could then say, look, I want to buy some water. I want it to be delivered to the space station, and the price I'm going to pay you for this water is going to be significantly less than the cost of launching it from Earth. So if you want to bid on this contract, go for it. You're going to try and launch it from Earth, you're going to make a loss, and it's never going to work. But if you can get it cheaper from space, people can turn $1 off that. Similarly, if NASA says, I want to buy 10 tons of stainless steel, this is the price. 10 tons of carbon, 5 tons of titanium, 3 tons of silicon, whatever. Putting a price down as something that production companies can aim for is going to be an important part of this. And one of the challenges that has to be overcome is transportation and propulsion. It's where I come in. We think we've got an answer. In fact, I'll be talking about this next week at a space conference in Sydney. I've got a paper wherein I go through some of the numbers on this. Other points, how are you going to pulverize your material? How are you going to separate the material? How the various metallurgical and chemical processes have to be done in order to transform your dirt into metal, or carbon, or water, or whatever it is you want to separate out. These are still unsolved problems. No one's really done a lot of this in space yet. People have ideas, and they're interesting ideas. They just need to be tested.
Yeah, but the other aspect on the space mining, Australia is one of the world leaders in mining on Earth, and the mining environment's very harsh, lots of dust and extreme temperatures and things like that. And so Australia, if we set up a base somewhere on another planet, like not just mining on asteroids, but it's talking about getting resources from wherever you are, so it could be on the Moon or Mars. Australia could provide some real high quality engineering and support. That's one area we could collaborate. Use what we do already great in Australia, do that on Mars or the Moon, because that's going to be critical. If something breaks or you've got big problems on another planet because your mining equipment's failed, and then all of a sudden you're going, well, we can't get water. It's a massive problem. And the University of New South Wales is actually doing a lot of work in this area, and they run a forum each year, or every couple of years, on mining in space.
Well, I'm afraid we've run out of time, but we could go on and on. What I'd suggest is that if you've got other questions, grab us after we finish. We'll be just outside for a few minutes, so please don't hesitate to come up to us and ask us or introduce yourself. I'd just like to make one other point before we finish. We are quite fortunate that we have a state government in South Australia that is really interested in building our space industry in this state. And they've done it in many ways. They were the first state to advocate for an Australian space agency. They've established a South Australian Space Industry Centre, and very soon they will be launching a new incubator and accelerator program for young people interested in starting their own space businesses, following the example of Peter a few years ago and Petty more recently. So that we are really interested in this state in having people like you with ambition, ideas, intelligence and good training actually trying to create your own businesses out of this industry. And so very soon there will be an announcement of the incubator and accelerator programs. $1 million a year will be committed by the South Australian government to these programs, and people like you are potentially the beneficiaries. You'll be able to receive specialised training in forming your own businesses, lots of assistance from mentors and experts on how to go about developing your technologies and developing your commercial ideas. So once you've finished your studies, don't discount the idea of becoming entrepreneurs yourself, following the example of two of our experts here today. So with that, I'd like to thank Peter, Paddy and Peter, and good luck with your careers.